So number one here, A is labeled as 29 degrees. And now I have no idea whether the diagrams I just sketched out are correct or not. I just drew two acute triangles randomly, just to have something to label. Side A is 18 inches, side B is 30 inches. So obviously my diagram is wrong because the scale is way off on those. But anyway, from what I have here, what can I find? First of all, do I have a side and its opposite angle? Yes, I've got A and A. So that's 18 over the sine of 29. Now the only other piece of information I have is the 30. That's a side, so it goes on top of the 18. What's going to go below it? Sine of B. B is the angle that's across from the 30. So now I will cross multiply and divide. Sine of 29 times 30 divided by 18. Gives us 0.8080. That is the sine of B. So to find B, we have to do an inverse sine of that number. And again, to avoid round off errors, I keep it in my calculator. I do second sine, second answer. And we get 53.90. So B is 53.90 degrees. That would give us then C of 97.1 degrees. How did we find that? Exactly, 180 minus those other two angles. Side C then could be found with the same process. We still have the 18 over sine of 29 degrees. Side C goes on top. It's going to be over the sine of 97.1 degree. So we will cross multiply and divide. 18 times the sine, 97.1. Make sure we close that parentheses up. Divided by the sine of 29. Gives us 36.84. So C, 36.84 inches. Now, if we look at that, does that answer look reasonable? Is the smallest side across from the smallest angle and the largest side across from the largest angle? Yes, it is. But is that the only possible solution for this? Why not? Yeah. We gave you an angle and two sides. But remember, we mentioned yesterday, an angle and two sides is okay, but there's issues if the side that is opposite the angle is the smaller of the two sides. And here that side, that 18 that's opposite the angle, is the smaller of the two sides, which is unfortunate. Because what that means is that angle could look like this, where this is an acute angle like that. Or it could look like this. That was an obtuse angle. So the A would still be the 29 degrees. This over here would still be 18 inches. This up here was what, 30? Yeah, 30 inches. And when we set this up, it's still going to be 18 over the sine of 29 equals 30 over the sine of B. And the sine of B still comes out to be 0.8080. And when we do the inverse sine, B still comes out, we still get 53.90 degrees. But how would we find B then from that 53.90? Well, remember, there are two angles when we look at our unit circle. That sine of 0.8080 There's another angle that has that same sign that's right over here, right? This is the 53.90. This angle here is 53.90. So the angle describing this is the supplement of 53.90. 180 minus 53.90, which is 126.10 degrees. So this angle here could be the 57 or 53.9, or it could be 126.1 degrees. And you can see that gives us a very different triangle now. So now we'll find this angle by subtracting from 180, and C is going to be much shorter than it was in the original. We don't know which triangle is the right one because we weren't given a picture. We're just given the information. So we're given information like that. Whenever the side that's opposite the given angle is the shorter side, we have to know if that second angle is acute or obtuse. Or we have to have a picture that we can draw. Now, where it's tough is, let's say that's like 89 or 91 degrees. If there's a picture, a lot of times you can't tell from the picture. All you can tell is it's close to the right angle. Sometimes you can't tell from the picture whether it's at 88 or 92. Which direction is it? Number 2 was kind of mean of me. Did anybody get an answer for it? Okay, well, that's good. Number 2 is not the nicest thing I've done to you this week. Do we have a side in the opposite angle? Do we have a side in the opposite angle? 21 over the sine of 40. The 43 goes on top. That's going to be over sine of C is its opposite angle. Ah, then you're doing it correctly. Yes. Sine of 40, oops, times 43 divided by 21. We get 1.316. What's wrong with that? It's bigger than 1. Sine cannot be bigger than 1. What this is saying is, with this angle here, if this side is 43 and this side's 21, this side is too short to reach back to this side. It'll never reach. So this cannot form a triangle. Does that make sense? You tried to do an inverse sine and then it gives you the domain error. Now, next step, if I do second sine, second answer, I get bad news. So yes, those are the issues. Again, notice this issue arose again. I'm given an angle and 2 sides. And what about the side that's opposite the angle? The shorter of the 2. That can be a problem. Now let me give you a couple that actually don't have major issues. Well, I've found through the years that giving you a problem that can't be done is the best way to teach you. After you struggle with it for a while, you remember it better. There. Good. So if we look at this one, does this one have the same issue? It's an angle and 2 sides, but the difference here is the opposite side is the longer of the 2 sides. So there is only one possible triangle that can be made here. So let's go ahead and find it. We have the 27 over sine of 41 degrees. The only other piece of information we have is the 21. What do we do with that? Perfect. 21 over the sine of B. And we will cross multiply and divide. So sine of 41 times 21 divided by 27. 0.5103. And so B is the inverse sine 0.5103. That sounds about right. Yeah, 30.68 degrees. So B is 30.68 degrees. Yes, C is 108.32. Again, we take 180 and subtract those other two angles. We get 108.32. We are now ready to find side C. We still have the 27 over the sine of 41. What do we do for side C? Perfect. C over the sine of 108.32. Because like we had mentioned, here we don't have a choice. We have to reuse information we've already calculated, so the round off errors are just going to have to be a part of it. So we're going to cross multiply this way. 27 times that sine of 108.32 . Yes, make sure you close the parentheses and then divide it by the sine of 41. 39.07. This is 39.07 inches here. I'm looking at that, does that make sense? Smallest side opposite smallest angle, biggest side opposite biggest angle. Yes, it does. Give that one a try. I'll give you a minute. So many of you have asked, does it matter how I lay out the triangle? No, it doesn't. But I just have this set layout that I just do because it's what I'm used to. I mean, if I draw it out the same way every time, I can label it, then it keeps the problem the same for me every time. So here I have A is 71 degrees, B is 42 degrees, and side C is 29 inches. Do I have a side and an opposite angle? No, but I can find it very quickly because I have two of the angles. Anytime I have two angles, the third one is standing right there. That's 67 degrees. Now I have a side and an opposite angle. So I have the 29 inches over the sine of 67. Equals, which side do I want to find first, A or B? It's always best if we find the larger one. So we're going to use side A. Now, in this triangle, it doesn't matter, but we get used to using the larger one first. That avoids that possibility of having different angles. And actually, well, technically, I should do the smaller one. We'll come back and I'll show you why. So 29 times the sine of 71. Divided by the sine of 67. Do I expect this number to be bigger or larger than 29? Got to be bigger because the 71 is a bigger angle. And it is, 29.79. So this here, 29.79 inches. So then we'll do the same for side B. 29 over the sine of 67 degrees equals B over sine of 42 degrees. Cross multiply and divide. 29 times sine of 42, again, make sure we close those parentheses. Divided by the sine of 67. 21.08. Inches. So we've got all the missing pieces. Now I mentioned it's important whether you pick the bigger or smaller side to work with. What do I mean by that? Well, let's say I have this triangle. I tell you that this here, let's just say it's 46 degrees. I know this side over here well, you know what? I'm getting ahead of myself. We're going to do that tomorrow. For right now, I think right before we jump into that, I will give you this example. We'll keep this at 46 degrees since I had it up there. I'm going to label this one in a very specific manner, though. Notice the angle is angle C. So I'm going to tell you that that's 46 degrees there. I'm going to tell you this here is 21 inches, and this here is 29 inches. Do I have a sine and opposite angle? No. Can I get one? Not with what I know here. Here we have one side, or sorry, two sides, and the angle between them. That angle between them is called the included angle, rather than the opposite angle. When we have that situation, rather than using the law of sines, we're going to use the law of cosines. The law of cosines is actually very closely related to our Pythagorean theorem. What's the Pythagorean theorem again? Yes, c squared equals a squared plus b squared, or a squared plus b squared equals c squared. Law of cosines, and you don't have to write this down now because we'll go through it more tomorrow. The law of cosine says c squared equals a squared plus b squared. I should make sure this is small. A squared plus b squared. But since c is not a right angle, there's an adjustment factor, correction factor. Minus 2 times a times b times the cosine of angle c. Look like fun? That's going to be our project. It's just a matter of plugging in the numbers. So c squared equals 29 squared plus 21 squared minus 2 times 29 times 21 times the cosine of 46 degrees. So you've got 29 squared plus 21 squared minus 2 times 29 times 21 times the cosine 46. You get that number, and then you got to square root it because that's c squared. So c is 20.88 inches. Now we have a side in the opposite angle. Now we can go use the law of sines. You never have to use the law of cosines more than once in the same problem. So you'd have that 20.88 over the sine of 46. Now, which one would I rather use here? The 21 or the 29? Yeah, we use the smaller one. The reason we use the smaller one is, in a triangle, how many obtuse angles can you ever have? One. You can never have more than one, right? Because that'd be more than 180 degrees. This is the biggest angle in the triangle, which means if there's going to be an obtuse angle, it's going to be angle A. What that means is if I tried to find angle A right now, there might be confusion between whether it's obtuse or acute. But I know angle B has to be acute because it's across from a smaller side. So if I find angle B first, I subtract from 180 to get angle A. I don't have to worry about when I do the inverse sine, is it that angle or do I have to do the supplement? Does that make sense? Again, this is a little bit of foreshadowing for tomorrow. For today, you have that packet I gave you yesterday, page 381, 1 through 17. I'm just going to have you keep working on those, finish up any that you don't have done. So if you have those done from yesterday, there is no new homework for tomorrow.